Okay, so this is the second lecture on OpenNebula that we'll deal with today. So I have decided to explain both the next lab sets to give you some more flexibility with regards to what sort of progress you can make on this. So we have VM creation and Sunstone familiarization. It might seem slightly counterintuitive to do the familiarization after we do the VM creation. However, without an active virtual machine in the cloud, you can't really play around with all of the settings and learn everything you need to learn. So that's why we do that. Plus, creating the virtual machine will give you some more insight into how actually the cloud itself operates and how it actually deals with the virtual machines inside it. So the most important concept behind all this is that the virtual machines depend on a sort of pyramid of features, technologies, whatever you want to call it, being installed and configured correctly onto the system, onto the cloud. So the cloud must first of all have a network infrastructure in place so you can actually connect everything with each other. And when I say everything, I don't mean just the virtual machine between them. I mean the one daemon that connects to the virtual machines and checks their status and runs the cloud and everything, to the virtual machines between themselves, to all of the cloud, to the outside world. So the networking infrastructure must exist before everything else so that everything can actually communicate with each other. You will then need to configure a host, so you'll need to have a virtualization host in place, so a computer or a server that can actually run virtual machines itself. You will then need to configure data stores, so you need to make sure that you have the actual hard drive space to hold all the images and templates and all the other information that is needed for the virtual machines to run. You then need to have an image. The images are essentially, we would say if you were building a computer, there would be the hard drives of that computer or the DVD-ROM drives of that computer and so on. You will then need to create a template, which is basically a recipe on how to cook up a virtual machine in the cloud. So it gives you all of the characteristics of the virtual machine that you want to start, like how many CPU cores, how much memory, what sort of networking, what sort of hard drives, what sort of images that uses, and so on. And then finally, we will create a virtual machine and build it and run it inside the cloud. So we start with the networking side of things. So the first thing that we must do is we must sort of change the structure of our networking inside our cloud. So at the moment, you should have an ENS33 network card that connects your Prometheus virtual machine to the outside world. What we want to do is we want to create a bridge called PR0 and essentially replace that. We will do this in a very manual way. So we'll go into etc. sysconfig network scripts and change the network scripts that govern the network cards of the operating system of Prometheus. I have the example files here, so the easiest thing for you to do is actually type the commands gedit for the ENS33 and gedit for the BR0, and you can actually, in fact, copy and paste the files from the lab sheet into the contents of those files. I would highly recommend, as the lab sheet says here as well, to make a backup of your ENS33 ifconfig file from that folder. I recommend you put it into your home directory. I had a student last week, I think, that they created an ES33.back, and that is actually recognized by the system, so that causes a bit of problems. So if you want to keep a backup of it, just cut and paste that file into your home folder, and that should be the safest thing to do. So you will create a new ENS33 file that will contain only these lines that essentially tells the network card that, look, you're now becoming a bridge. The NM controlled equals no means network manager controlled equals no. So your new network card will not show up on the top right corner of the graphical user interface in Linux. And then you will create the BR0 network card, which will have all of this information inside it. Obviously, the big red letters need to go and the question marks need to go. They need to be replaced with the IP address of your Prometheus. Essentially, whatever IP address your ENS33 had so far needs to go onto this file here. Once you do this, you can then restart your network, and then your new ifconfig will still show you an ENS33 card coming up, but it will not actually be configured with any IP address or anything like that. It will just be like a dummy network card. And then under that, you should have a BR0 network card show up in ifconfig that will have all of the information that you need in order to connect anywhere. And of course, you should be able to still ping Google and do everything else. Now, once we're here, just make sure that you restart OpenNebula, and while you're at it, just make sure that you set it so that it starts every time automatically whenever the computer starts. So that's what the check config command does. And now it's time to actually go inside OpenNebula, so everything from this point onwards in the lab sheet will actually happen inside the browser itself. So once you're here, we're going to do the second task, which is add a virtualization host. So essentially, you will go to infrastructure, you'll go to hosts, and you will click on the green button. What you need to add there is the host name of your Prometheus. So simply Prometheus NetLab EE-Port AC UK. Of course, make sure, check for one last time, that your host name is set correctly on your virtual machine, on your Prometheus. So the way to do this is to actually open a terminal and type hostname and see what the system comes back with. Whatever the system comes back with, copy it with your mouse, paste it in that box, and that's the safest way to make sure that you're giving this the same host name as what your computer actually has. Once you do that, you click create, and the host should appear here, and the status should, after a while, be turned to on. This is the first hurdle that you might come across. If it goes to error, it means that there's something wrong. The something wrong can only be one of two things. Either you forgot to install the OpenNebula Node KVM RPM onto Prometheus, so you skip that step in the first lab sheet, okay? Or your passwordless SSH has not been correct. So this means that OpenNebula itself cannot actually communicate with the host because it needs to be able to log into that host passwordlessly and actually work with it. Okay, so it's either the Node KVM or the SSH that hasn't been done correctly to this point. There's really no other reason why this should turn to error. If it does turn to error, check those two things, and then if they still look okay, then just call us and we'll try and figure it out. Once you do this, you then go on to the next part. So you need to check that your data stores are there. So by default, with the installation of OpenNebula, 3 data stores should be there, system, image, and file. All right, so they should exist in that area of your cloud, and you shouldn't need to touch them, you shouldn't need to do anything about them, but they should definitely be there. If they're not there, something has gone horribly wrong, and you need to figure it out. After that, we go on to networks. So we have created the basic backbone infrastructure with BR0 physically on the computer, on the Prometheus. So you need to tell the cloud as well to actually go and be able to use that BR0. So that will be a bridge that we're building. So you'll create a new network card, you'll call it BR0, you'll tell it that the physical device, because it needs to take the characteristics of a network card from somewhere. So you're going to tell it that the physical device is ENS33, even though ironically that is actually a virtual network card because we are inside the virtual machine, but it's fine. Okay. Go to address. The IP address that you give it there is simply the next available bridge for you. Okay, so your computer might have an IP address of 148.197.28.20. Then your Prometheus will have +50, so that will be 28.70. Then this virtual machine that is bridged in here will have the next available bridge, which will be 28.120. Okay, so, and in fact, we still have one more bridge available after that to use, should you need to in the last lab sheet, which is something that we'll explain in the last lab sheet. All right, so choose the size of 1, because you only want to give one IP address to that virtual machine. Go to the context tab, give it the network address 280, subnet mask 2550, gateway 28254, and DNS 28251, which is our new DNS server that we're using. Click create. The network card should be created into OpenNebula, and then we need to create the images. So this virtual machine that we were building will have two images that it will depend on. So it will need to have a blank hard drive so that we can install the operating system onto it, and then it will also need to have a DVD that the operating system will be installed from. So the first image will be vPrometheus 0. It will be a generic storage data block. It has to be persistent, and I want you to really look into what persistent and non-persistent means with regards not only to the image but to the virtual machine being instantiated as well. Okay, so I want you to really understand what this actually means. In this case, a persistent image means that once we build it with the operating system will stay on it forever. So all of the data that's being written onto this image will be written onto this image forever. So it behaves like a normal hard drive. Okay. And then choose empty disk image, give it a size of 10 gigabytes, and most importantly, don't forget, the format must be QCOW2 for the file system, and then you click create. That image should be created and should turn into status ready straight away. The second image will be CentOS. You need to set it to read-only CD-ROM type, and the easiest way to do this is to select upload, choose file, and get the CentOS ISO from your home directory. If it's not in your home directory in Prometheus itself, you will need to SCP it from the actual host itself, so you have it as an image in your home directory because you will need it. Click on create. You notice that the image is now there, but it's locked, and it will take maybe a couple of minutes for it to be completely uploaded into the cloud and turned into ready so that you're ready to use it. Once your images are built as well, we are now ready to create a template for the virtual machine that we want to use. So we can call the template VP0 or whatever you like really. Set KVM as the hypervisor because this is the hypervisor technology that the virtual machines inside our OpenNebula installation depend on. Okay, so a hypervisor is what gives your system the virtualization capabilities. All right, so VMware, for example, is a hypervisor. KVM is one of the oldest ones around on Red Hat. It actually depends on Zen, what it used to be called in the past, which was the first hypervisor that Red Hat made, and it was a horrible thing. Lovely. But yes, give it 2 gigabytes of RAM, say yes to enable host resize so that you can actually resize it, so give it more CPU cores and so on. Give it 1 physical and 1 virtual CPU, so we're not doing any overcommitment or undercommitment at this point. We'll just keep trying to keep it as simple as possible. And then go into the storage tab, select vPrometheus 0 for disk 0, and then click on the add, go under it, and go to disk 1, and assign the CentOS to it. So we're giving it a blank hard drive, and the second one we've given it to be the DVD. You need to go to the network tab, select the bridge, and then you need to go to OS and CPU and select x86-64 for the architecture. And most importantly, you need to choose disk 0 for the first boot and disk 1 for the second boot. And by choosing them, it means that you need to select them. You need to check the boxes on the left. It's not enough that you have them in the correct order in there. The boxes next to them actually need to be checked, because even though you have those images available for the virtual machine template, if you want to use them, you need to keep the boxes checked. All right. If you don't, your system will not boot, and that will be the reason why. Once that's done, you go to input output and select VNC, because that's how you actually connect to the virtual machine that you will build in your cloud in order to view it. And then you click create and your template should appear. What happens after we have a template in our system? We need to get our virtual machine to run, or in OpenNebula terms, to instantiate it. So we need to take the information from that template, take the images, all the network cards and everything else, and get the virtual machine to run. All right, so in order to do this, you go to Instances, VMs, click Add, select the VP0 template, name it whatever you want, check that capacity, disks and network are correct, and click Create. The VM will be created. It will obtain your first usable IP address, which will be the bridged IP address that you've given it, and is the only IP address that you have. And the status will be prologue for a while, and then it will change to booting and then finally running. This for a while in the prologue status can actually be quite a bit as well. Okay, we have tried to make the dumb things as fast as possible, NVMe hard drives and all that, but this is the point where your images get copied from the image data store onto the system data store. So this is the point where a data transfer has to happen so that the virtual machine can start and run somewhere else. In the beginning, in the first time you do this, it might not be so long, but after you build the virtual machine, so after you build the image with an operating system and everything, that can actually take up to like 5 minutes, especially when you terminate the virtual machine. So you need to be a bit patient with this, but it can actually take a bit of time. Once it's running, you click on the VNC icon, you connect to the virtual machine, and you can do a normal CentOS installation. Just do everything default GNOME desktop, install it, and that's it. Once it's running, go in, make sure you set the host name correctly, and you give it the correct IP address on the bridge interface, and then that should be it. As for the networking capabilities of this, because it's bridged on Subnet 28, you should have full internet access on this virtual machine as it is. Okay, so it's the most direct way to connect a virtual machine in the cloud so that it actually has internet access from its conception. And this is where the first lab sheet ends. So you've built a virtual machine, it's running, it has an operating system inside it. The next step is to play around a little bit with Sunstone in order to figure out where everything is. So Sunstone is the web interface that manages everything on OpenNebula. Okay, remember you can also have a command line interface if you really want to be hardcore about it, and you can manage the entire cloud with commands in a terminal on a black screen, and then look really cool to your friends. However, the vast majority of people will actually prefer, to have a life and not learn a million more commands. And so you can have different views in OpenNebula itself. So there are 3 basic views that you can have, and that's admin, VDC admin, and cloud user. At the moment, you logging in as user OpenNebula have always been on admin mode. So you can see and you can configure absolutely everything about your cloud. So you can make new images, you can play around with templates, you can add and remove new hosts, and so on. The second level of this is a VDC admin, so a virtual data center admin. So you can compartmentalize, you can split your entire OpenNebula cloud into different VDCs. The number of the VDCs depends on how many resources you actually have in your cloud. And you can give admin accounts for each of the VDCs. You can choose how much freedom you want to give to those virtual data center admins, and they can then, whether you let them or not, they can create their own images, their own templates, their own networks even, and then basically allocate users to actually use the virtual machines that they create or the resources that they create, which will be the cloud users. The cloud user in the end will be the bottom of the food chain user that can pretty much only start up a virtual machine that's been pre-configured for them, and at best they can give some more resources to it if they need to, so that they can give it some more CPU cores or some more RAM and so on and so forth. Okay, it all depends on how you want to run it, on how how much freedom you want to give everybody with this. In our case, an example would be, for example, Cedric and Alex, our system administrators, would be the admins of the cloud that we have, and then they would have different virtual data centers, one for students, one for researchers, one for staff. Then each of these would possibly have an admin account. So the researcher admin would have a lot of power because they would need to give and change the resources to their users. The researchers would be the cloud users in the end. And in a similar way, the academics would probably have one person that could manage the thing, and then have all of the academics as the users in the end. Then you have students that VDC admin, the student VDC admin, you wouldn't really give them much to do, only perhaps the ability to create one virtual machine and use it for all the students. And then finally, the students would be the cloud users in the end, which is pretty close to the scenario that I want you to have by the end of this module. Okay, so the last lab sheet is populating the cloud, is basically building a cloud set out pretty much like this. So one of the first things that you need to master is the various different running states of a virtual machine in the cloud. So you don't just have on and off or suspended, you have different ways that the virtual machine can exist in the cloud itself. So if you have a virtual machine that's running, you can suspend it, so the VM state is saved and it's kept on the host. So those images that were copied from the image data store to the system data store are still there. The VM still shows up on your cloud as active, but it's essentially suspended, put to sleep. You can power off, and you can do that the hard way as well. So that powers off a VM but keeps it in the host. So it's like instead of putting a laptop into sleep, you actually press the power button and you switch it off completely. However, it's still available in the cloud. So one of the users one of the end users can actually start this up. You have stop that that saves the VM state and takes it to the system data store, so it moves it away from the running VMs in the system. You have undeploy, which powers off a VM and removes it from the system as well. You have reboot, which reboots the system. You have delete with the option to recreate as well, which basically cleans the virtual machine and moves it to pending. When I say cleans the virtual machine, it all depends on whether that virtual machine was instantiated as persistent or non-persistent, because you can have a virtual machine that has a persistent image, so you build the operating system on it and the operating system will always exist, but then you can have users connect onto that virtual machine. You can have that virtual machine instantiated as non-persistent. A user will connect to it, log in, work, do whatever they want on it, and once they log out and the virtual machine is powered off from them, everything will be reset back to initial settings. So if the user changed the wallpaper, the next person that starts up that virtual machine, the wallpaper will have been reset back to default. Okay, so that's what delete actually does. You can have shutdown, which powers off a VM, cleans the host, and the VM is removed from OpenNebula completely. And then you have delete, which VM is immediately destroyed regardless of state, and the running image the running template, is completely destroyed and removed from the system completely. Okay, so if something goes horribly wrong with your virtual machine, so if you haven't configured anything on something on the images and so on, then this is what you must do. Okay, if you delete a VM, it doesn't mean that it will delete the operating system on the image that you used for that VM. Okay, the image was persistent and it will stay persistent even if you're not using that image for that particular VM anymore. All right, so you need to familiarize yourselves with those running states a little bit. So push the buttons, see what happens. The whole point of this lab sheet is for you to familiarize yourself with OpenNebula and the interface about it. If you do break something, it doesn't matter. You haven't really built anything yet. You've only just built one virtual machine, and even if you do mess this up, you can still build it again, and it's not the end of the world. All right. So other VM actions that you can have. So I want you to look at all of the buttons up there and play around with storage. So I want you to, for example, try to attach a new disk, so you can create a new image, give it a small size like 100 megabytes so that it doesn't copy for hours across the data stores, and attach it onto the virtual machine. You can even do this while the virtual machine is running, actually. You can do the same with a network card, so you can detach or attach network cards, and you can try to take snapshots of the system, so basically live backups essentially of the system, and you can try to resize the VM's capacity. You should have enabled that enable resizing when you're creating the template, so at least, the very least, the CPU cores should be able to resize. The easiest test to do for this is take the vCPU value of 1 in the template and change it to 0.5. Okay, so it will give it half a core instead of 1, make it a bit slower, but you're not really doing anything to it, so it won't matter that much. You need to also be careful about the permissions of your images, templates, and virtual networks. They all need to be in sync. So if you have a virtual machine that is running, then the properties, the permissions on the template, on the images that the template depends on, and the networks that the template depends on, need to be the same. So you need to make sure that whoever can start a template, they have enough permissions to actually use the images of that template as well. Then I would like you to create some groups. So you can go to the admin tab, create an administrator. So that's where we're essentially creating the new VDCs. It all depends on the groups that you create. So you create a group called students, and that will automatically create a user that's called students admin. Give it a password of localhost 1, and you'll have that user available there. And the ACLs connected to that will look something like this. So you have your virtual machines, who can actually use a virtual machine. You have users 1, user 2, you have groups of students, and so on. So this way you can basically monitor all of the permissions for everybody involved in your cloud. And it might seem trivial at this point, but a big percentage of the administration of the cloud actually has to do with ACLs, has to do with access control lists, has to do with permissions of usage of resources of everybody in there, because you will have lots of users and you might have multiple groups of users in the end. You need to make sure that everything here is neat and tidy, because if it's not, nothing will work. All right, if you're missing the permissions, then your users will not be able to do one or another thing that you want them to do there. So with the virtual data centers themselves, mind you, also the actual look of what you see in OpenNebula might be a bit different, because I think when I took these screenshots for this, I think I was using OpenNebula version 5, and now we are on to 6.2. So if it doesn't look exactly the same, it's not the end of the world. There's a graph later on that definitely doesn't look like that. But you can have different views. So you have the virtual data centers that you can see with all of their resources that connect onto them. So when you switch onto a VDC admin, so you log in as a student admin user, then you can see that you can create other users below the student admin there. You can actually create students and so on. You can assign quotas with regards to how many CPU cores or how many virtual machines they can actually start, and so on. And then finally, you can switch onto a normal student account. So that will be the end user. So in order for this to be successful, a student must be able to log in and actually see a virtual machine that is already available for them. This means that there is a template that has the correct permissions for the students to be able to actually start it up and run it. A very important mistake that happens here is if you do this, the virtual machine that the students are supposed to be using must not already be instantiated. So if it's running already, so if it exists in the cloud already, it will show up as red. The image will show up as red, and you will not be able to start it. And the reason why the image will be showing up as red is because that image is persistent, and you cannot use the same persistent image in multiple virtual machines. So if you had non-persistent images, you would be able to start multiple instances of the same virtual machine for lots of students. But it's not the case with the virtual machine that you built already. So you need to be a bit careful about that. So before you log in as student, you need to make sure that you go to your instances as one admin and delete the virtual machine that's running in there. All right. Once it's running, you should be able to see some statistics. So this graph, for example, doesn't look like this anymore. But you should be able to see CPU usage, CPU hours, memory usage, and so on onto the system itself. And that will eventually be the end of the lab sheet for you. So by this point, you should have a different group of users that should have a student admin account that can administer those end users that will be just normal students. And you can essentially start up and use a virtual machine as an end user that knows nothing about how the cloud actually operates, that you, however, have built for them in order to use. Okay, and that's the whole concept behind you having a cloud. All of this background work of the images, templates, virtual networks, access control lists, and everything else, they are of zero significance to the end user. Okay, the end users don't need to know. So the end users of the cloud will need to log into a web interface or similar and click on a box, select maybe how many CPU cores they need or how much RAM, and start up a virtual machine from there, and that's it. Okay, everything else is legwork in the background to keep the thing running and keep the thing running correctly. All right. Any questions about all this? Okay, so be careful on the various steps along those two lab sheets. I've told you where you can get stuck on them. And if you see that something is not there, just call us. But remember, it's only one virtual machine. And if you do mess it up, like if you delete the image by mistake, it will take you another 5-10 minutes to create another one. It's fine. Okay, so don't be afraid to play around. The worst thing that you can do is break your OpenNebula installation. But then again, you can do it again. And also, perhaps it's a good idea if you want, once you're finished with the OpenNebula setup lab sheet and you have your OpenNebula running, or even at the point in the second lab sheet where you add the host onto the system, you can power off your Prometheus VM and make a backup of it. So before you start playing around with building the virtual machine or with this particular lab sheet, Familiarisation, you can actually take a backup and make sure that, if you do break it, then you have another backup that you can revert to and you don't need to worry about it. Okay? Thank you very much.